Okay, everybody, Mr. Quick here. Today we're going to jump into Eureka Math / Engage New York Math, Module 2, Lesson 3, Division of a Fraction by a Fraction. Now, quickly, we have looked at dividing a whole number by a fraction. We have looked at dividing a fraction by a whole number. And now today, we're taking that one step farther, and we're going to be looking at dividing a fraction by a fraction. So buckle in, it's going to get exciting here. All right, we're going to go through a couple of different examples and kind of show you how to do it, and then we'll talk even more in class about it. So let's get started. Okay, first a little warm up, and this is going to go along with our lesson today. If I said 8 divided by 2, you would know that that equals, you got it, 4, right? Now if I said 8 ones divided by 2 ones, you would hopefully recognize that 8 ones is 8, 2 ones is 2, and the answer is still 4. What about 8 tens divided by 2 tens, right? 80 and 20, but we're still going to get 4. Seeing a pattern here, right? We could go 8 thousands divided by 2 thousands. We're still looking at, hey, the thousands are the same, right? They kind of cancel each other out there, right? So we're still looking at 4. What if I said 8 tenths divided by 2 tenths? Both are less than 1 now. Like, we were getting into the thousands. Now we're going smaller. We're less than 1. But again, same base. So we're looking at 4 once again. If I said 8 thirds divided by 2 thirds, hopefully you recognize that, hey, we still have the same base, so we're just taking 8 of something and dividing it by 2 of the same thing. Answer is once again 4. So, taking that same principle, if we looked at this math problem, 8 ninths divided by 2 ninths. That may look a little complicated if you're just thinking about it in terms of, well, I've got this one fraction, I've got to divide it by this other fraction, I've got to figure out the ninths, I could do the keep, change, flip, I could do all this stuff, which is all true. But if you look at the fact that they both have the same denominator, we're talking about the same kind of unit here. We're talking about ninths. So since these are the same unit, we're looking at 8 of something divided by 2 of the same thing. We're just looking at how many times does 2 go into 8? How many times does 2 ninths go into 8 ninths? And we're going to get 4 once again. Okay, I'm going to show you a visual way of looking at this. If I set up a tape diagram, and I'm going to break this into 9 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, good. 9 parts. Because there are 9 parts in the whole. I know that 1, 2, 3, 4, 5, 6, 7, 8. This represents 8 ninths of that total. Now, I'm going to change colors to make it just even look a little bit more visual. If I break that into 2 ninths, well, here's 2 ninths, right? 1, 2. Here's 2 ninths, right? 1, 2. Here is 2 ninths, 1, 2. Here is 2 ninths, 1, 2. So, or 1, 2, excuse me. So I've broken this down, so this whole section here of the total is 8 ninths, and if I divide that into 2 ninths, we have 1, 2, 3, 4 sets of 2 ninths. So we get our answer. The quotient is 4. Okay, we have that. I'm going to erase this because I want to also show you and ask you this question. Would the keep, change, flip work? Okay, we have 8 ninths. We're going to change the division into multiplication. We're going to flip 2 ninths into 9 halves. 8 times 9 gives us 72. 9 times 2 gives us 18. Can we simplify this? Well, I know we can divide both of these by 9. Right? That's our constant or our magic number. We're going to end up with 18 divided by 9 is 2. 72 divided by 9 is 8. I can do one of two things. I can say 2 goes into 8 4 times, but if I didn't recognize that and I just have my 8 halves, I should at least see, hey, I can divide both of these by 2. We end up with 4 over 1, which again is the same thing as our answer, which is 4, just the whole number 4. A lot of different ways of looking at that, but basically dividing these fractions, you can do it multiple ways. Do it the way that's comfortable for you. Let's do another example. Okay, we're going to do 9/12 divided by 3/12. Different ways to do it. Once again, you could do keep, change, flip. I'm going to kind of partition that off there. So we could do 9/12, change the division into multiplication, flip 3/12 and turn it into 12 thirds, and then multiply. 9 times 12. Well, I know 9 times 10 is 90. 9 times 2 is 18, so that's 108. 12 times 3 is 36. I know I can divide both of these by 12 because they have 12 in both of them, right? 36 divided by 12 gives me 3. 108 divided by 12 gives me 9. 3 goes into 9 3 times. So my answer is 3. And if you didn't see that, you would at least see, okay, I've got 9 thirds. I'm going to divide both of those by 3. 9 divided by 3 is 3. 3 divided by 3 is 1. 3 over 1 is the same as 3. Okay? We could also do a visual model. I'm going to start by creating my tape diagram, and I know there's going to be 12 parts to my tape diagram. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, I'll add on one piece here, 12. Got 12 parts. I know that I want to fill in 9 of those parts. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that section is 9/12. Okay, now I want to break that section into 3/12. So every set of 3. There's a set of 3. 1, 2, 3. That's 3/12. Here's a set of 3. 1, 2, 3. That's 3/12. Here's a set of 3. 1, 2, 3. There's 3/12. Doesn't matter about that because we're only looking at the 9/12. So how many sets of 3/12? We have 1, 2, 3. Okay, different ways of doing it, right? But you're still getting to that same answer. You also see that when we had our 9/12 divided by 3/12, the denominators, we're talking about the same thing. So we're basically saying how many times does 3 go into 9? It's going to go in 3 times. Okay, that works because the denominators are both the same in this case. Now let's do another example. Okay, our next example. This one may be, I shouldn't even say it'll be a little more difficult, but I want to show you that, hey, look, 7 and 3 are not easily compatible. The other ones were easily compatible, right? 3 went into 9, 2 went into 8. 3 does not go into 7 evenly. So let's start with our visual model. I know I need to create 7/9, so I've got to create a tape diagram that has 9 equal parts. There we go. 1, 2, 3, 4, 5, 6, 7, 8, 9 parts in my total. I'm going to fill in, because we're talking about 7/9, I'm going to fill in 7 parts. 1, 2, 3, 4, 5, 6, 7. So this section is 7/9. The whole thing is 9/9, but we're looking at 7 pieces of the total. And I'm going to divide that into 3/9. So every 3. So we have 1, 2, 3. That's 3/9. We have 1, 2, 3. That's 3/9. And then hold on. We only have one other section here. So looking at this, what's left is 3 pieces, but I'm only using one of them. So that, in this case, is 1/3, right? Because there's 3 pieces left that I didn't use, but that within the 7/9, there's one part of that section. So that's 1/3 left. So how many 3/9 go into 7/9? 7/9 divided by 3/9? We have 1, 2 as a whole number, and then 1/3 as my mixed number. Let's look at another way. You can also look and say, well, 3 goes into 7 2 times, right? 3, 6. There's 1 left over. But, hold on a minute. Denominator can't be 9ths. That doesn't work in this case. So, let's look at our keep, change, flip. We've got 7/9, change, division, multiplication. Flip 3/9 to 9/3. 7 times 9 gives us 63. 9 times 3 gives us 27. I know both of these, my magic number here to simplify, both of these can be divided by 9 because there's 9 on both sections there. 27 divided by 9 is 3. 63 divided by 9 is 7. We end up with 7/3. 3 goes into 7 2 times. There's 1 left over. And now the denominator stays the same. Okay, there's other ways to look at this as well, other visual models. We'll talk more about that in class, but I just wanted to show you some of the key ways we're going to be looking at this going forward. Thank you for watching, and we will talk more when I see you face to face. All right, thanks.